Magam na araw, my name is Princess Rian Borabon from 7 Agap A, and I will be discussing how to solve the velocity, wavelength, and frequency of a wave is. Let's first look at the learning outcomes. First is define what the velocity, wavelength, and frequency of a wave is. And the second is to solve complex problems involving velocity, wavelength, and frequency. So what is velocity? Velocity is the distance traveled by a wave per unit time. It is represented by lowercase v and the unit is in meters per second. The formula that we will use to solve this velocity is equal to wavelength multiplied by frequency. Moving on to the wavelength. Wavelength is the distance between two successive crests or troughs. It is represented by a lambda sign and the unit is in meters or nanometers. But we will use this in meters. The formula to get the wavelength is equal to velocity divided by frequency. As represented in the picture, that is what a wavelength looks like. Now let's get into frequency. It is the number of cycles per second and it is represented as lowercase f. The unit that we will use is in hertz and the formula can be either frequency is equal to velocity divided by wavelength or 1 divided by period. It depends on what's given on the problem. Before we proceed, if you're having a hard time memorizing these formulas, just remember this triangle of velocity, wavelength, and frequency. For more information, a period is the time for one complete wavelength to pass by a given point. It is represented as uppercase T and the unit is in seconds. The formula that we will use to get the period is equal to 1 divided by frequency. Since we now know the formulas, let's get to solving problems. I will give you 20 seconds to analyze and solve the problem, and after that, I will show the answer. So, problem number 1. A wave of a wavelength of 1800 nanometers. It completes one wavelength in 1 minute. What is the wave speed and frequency? Let's solve this using Gresa. Now the givens are wavelength is equal to 1800 nanometers and the period is 1 minute. Considering that the wavelength should be in meters and the period is in seconds, we will convert both of these givens in the appropriate unit. The formula to convert nanometers to meters will only multiply 1800 nanometers to 1 times 10 raised to negative 9 meters. And that will give us the answer of 1.8 times 10 raised to negative 6 meters. For the period, we will only multiply 1 minute to 60 seconds. That will also give us 60 seconds. And the required in this problem is speed and frequency. Since we now know what we are looking for, we can now go to the equation. For the equation, frequency is equal to 1 over period and the speed is equal to wavelength multiplied to frequency. For the solution, we will just rewrite the equation with the givens. Frequency is equal to 1 over 60 seconds and speed is equal to 1.8 times 10 raised to negative 6 meters times 0.02 hertz. That will give us the answer of frequency is equal to 0.02 hertz and speed is equal to 3.6 times 10 raised to negative 8 meter per second. Now let's get into problem number 2. The problem here is solve for the wavelength of a light wave with a period of 0.5 seconds. Time is up. Now the givens are period is equal to 0.5 seconds and speed is equal to 3.0 times 10 raised to 8 meter per second. Now for the required wavelength and frequency. In the equation, we will use wavelength is equal to speed over frequency, and frequency is equal to 1 over period. The solution, we will rewrite it again. Wavelength is equal to 3.0 times 10 raised to 8 meter per second over 2 hertz. And we will cross out hertz and seconds. And frequency, 1 over 0.5 seconds. And that will give us wavelength is equal to 150 million meters and frequency of 2 hertz. Now let's get into problem number 3. The problem here is a wave have a speed of 8 times 10 raised to negative 4 meter per second and have a wavelength of 450 nanometers. Calculate the period and frequency of the wave. Time is up. Now the givens are the speed is equal to 8 times 10 raised to negative 4 meter per second and the wavelength is 450 nanometers. Now we will convert it. 450 nanometers times 10 raised to negative 9 meters is equal to 4.5 times 10 raised to negative 7 meters or 0.00000045 meters. Now for the required is period and frequency. Now, in the equation, period is equal to 1 over frequency, and frequency is equal to speed over wavelength. Now for the solution, we will write it again. Frequency is equal to 8 times 10 raised to negative 4 meter per second over 0.00000045 meter, and we will cross out the meters. In period, 1 over 1777.78 hertz. That will give us the answers of period is equal to 5.62 times 10 raised to negative 4 or 0.00000562 seconds. Frequency is equal to 1777.78 hertz. That will be the end. Thank you for listening.